Okay, welcome back. This is actually the second slides, the second video on the topic on potential divider. So let us look at the contents again. So in the first slide or first slide, we have actually talked about what is a potential divider and how does it work. And so now we are at the second slide. We're going to talk about the users and application. And then subsequently in the third slide, we're going to talk about the application of the potential divider if it is a resistive wire instead of a resistor. Alright, so first of all, prior knowledge again, we need to know these three things already: the series parallel circuit, the Ohm's law, and the effective resistance. This already has been covered in the previous video. And then of course in the previous video we learned a new formula, which is the potential divider formula. Alright, V out equal to R2 over R1 plus R2 times V in. Nothing special about this, just the ratio of the resistors. And now let's move on. Okay, so let's recap what is a potential divider. Alright, so a potential divider divides the voltage within a circuit, so the parts of the circuit only receive the voltage it requires. So potential divider consists usually of two or more resistors connected in series to a power supply. Nothing special about this, we also learned in the previous slide. Alright, let's move on. So in this lesson, we want to study the uses of the potential divider. But before that, we need to understand some very basic function of how to turn on and off a circuit. Now, let's say you have a device here that is rated at 3 volts. What do I mean by rated? Rated means for normal operation, alright, what is the voltage that the device will draw? So in this case, this device draws a voltage of 3 volts for normal operation. Alright, so if this device draws 3 volts and you're connected to a power supply that only supply 1 volt, will you expect it to be operating normally, or do you expect it to be not operating normally? So obviously if you have a 1 volt supply, it will definitely be very dim or you'll be off, right? So in this case, let's say that the device is off. Okay, so how do you rectify this issue? Okay, the simplest way is to have more voltage. If you have more voltage, you'll definitely be able to turn on the lamp. And in this case, if you have 3 volts and you're rated at 3 volts here, obviously the lamp will turn on. Now, why do we need to learn this? We need to learn this because the potential divider has the potential to change the voltage from 1 to 3 volts. And this we're going to explore later. And when it can change from 1 to 3 volts, you can effectively on or off a device that it is connected to. Alright, so let us study this in detail. Imagine that the same lamp is connected to a potential divider here. The potential divider is a 1 ohm here and a 10 ohm here connected in series. Now, if this is 1 ohm, what is the output voltage? Let's calculate together. The output voltage is going to be equal to 1 over 1 plus 10 times 10. Alright, so you're going to get approximately 0.9 volts. I know that this was just an approximate, not 3SF. Just bear with me. So this is definitely going to be much lesser than 3 volts. And this device is off. Now imagine if you could suddenly change the resistance of this resistor here. Let's say now it becomes 5 volts, 5 ohms. Alright, now it becomes 5 ohms. What will happen to the V out? Let's calculate again. Right, in this case, the V out is going to be equal to 5 over 5 plus 10 times 10. So if you work out, you'll get 5 over 15 times 10, which is 3.33 volts, which is larger than 3 volts. And it is very close to the operating voltage, so you will turn on. So if you can find a device here that can change its resistance, you can actually on or off, alright, depending on the resistance of the resistor here. And you can on and off a device that's connected to it, right? So just a simple summary: the higher the resistance, the higher the potential difference, and hence the device will turn on. Conversely speaking, the lower the resistance, the lower the potential difference, and the device will turn off. So how can we find a resistor that can actually change between a high and a low resistance? Okay, I'm going to introduce to you the idea of transducers, but we are not going to explain about transducers in this lesson. I'm just going to explain a bit on the property of this particular transducer, which is a light dependent resistor. So what happens is that a light dependent resistor at low light or in a dark room, you will have very high resistance, and when it is in a daylight or bright light condition, you will have very low resistance. Okay, so using this information, let us explore a case. Okay, first of all, this is how the diagram of LDR or light dependent resistor looks like. Okay, now let us explore a case where you replace the resistor here with a LDR. Let's imagine that this LDR has when it's bright, has a low resistance of 1 ohm, and when it's dark, has a high resistance of 100 ohm. Now let us calculate the V out in these two cases. Alright, in this case, I change the rated output voltage to that of 8 volts supply, and then we're going to do the calculation now. So first of all, let us just consider the output voltage, alright, when it is bright. Okay, that means there is daylight. Alright, so the output voltage is going to be equal to 1 over 1 plus 100 times 10. So what is the answer? Let me just punch into my calculator. Sorry, I made a mistake here. This should be 10 here. So it's actually 0.9, approximately 0.909. Alright, so if it's 0.909 is so much lesser than 8 volts, so it will off, right? Now what if you have a dark day? Is at night, of course. No such thing as dark day, is at night, so it's black. Now what happens to the output voltage? The output voltage is going to be 100 over 100 plus 10 times 10. Okay, so what do you get? So you get 9 which is larger than 8 volts. Now in this case, the lamp will turn on. So can you tell me what kind of device is this that you want to turn the lights on at night and want to turn off the lights in the daytime? Basically, you can call this a daytime light saver, alright? Because let's say you have a garden and you want the lights to be on by itself, so obviously you can just put the sensor there, and then you will turn it on at night and turn it off in the day. So this is a very, very good example of how the potential divider can be used. Alright, so let's move on. So how do you explain how the device works? So during the daytime, the LDR has low resistance, and the potential difference across the lamp is low, less than 8 volts, which is actually significantly lesser. Hence, the lamp is off. So if you are asked to explain in an examination, this will be how you should answer with all the keywords. Now, during the nighttime, the LDR has high resistance, and the potential difference across the lamp is high, and hence the lamp turns on. Alright, so you realize how these two are different from each other. Low resistance, alright, low potential difference off, high resistance, high potential difference on. Alright, so that's just the straightforward way of explaining. So that's all it is for the second part of the potential divider. So let's go on to the next video. I hope to see you in the next video on how to use a resistive wire. Thank you and have a nice day.